Welcome back to my channel. For this video, I will continue discussing about number system, and we'll discuss how to convert any number to hexadecimal. Let's start off with conversion of binary to hexadecimal. So to easily convert from an integer binary hexadecimal to hexadecimal, binary number to hexadecimal, you just have to break the binary number into 4-bit sections starting from the right to the left. And just like our conversion earlier to octal, you just have to add 0 to the left of the number if there is any section that does not reach 4 digits. So once you're done, convert the 4-bit binary number to its octal equivalent. Let's start off with an example here. The example is 1 1 1 1 1 0 1 1 0 0 1 1. So to convert this to hexadecimal, you simply have to break the binary value into 4-bit sections. So we have 0 0 1 0 starting from the right, and then the next section would be 1 0 1 1, and followed by another sections of 1 1 1 1. And since there are no other digit remaining, then that's it. So we have successfully grouped our binary numbers into 4 digits each. Now, so given that, remember your 8 4 to 1 placements as discussed in the other video. And so for 0 0 1 0, that will be on, or that will be a representation of your 2, so that will be 2. And 1 0 1 1, if you try to remember 8 4 2 1, that would be 8 plus 2 plus 1, that's equivalent to number 11, which is equivalent to letter B in hexadecimal. Remember that your numbers in hexadecimal, when you reach 10, is equivalent to A, 11 is equivalent to B. Right? So for the last partition, you have 1 1 1 1, and that's a representation of your 8 4 2 1. So 8 plus 4 plus 2 plus 1 is 15, and that is equivalent to letter F in hexadecimal. So therefore, your binary 1 1 1 1 1 0 1 1 0 0 1 0 to hexadecimal is equivalent to FB2. For our next example, we try to give an example here that does not reach 4 digits for the last partition. So again, we subsection this, we divide this by 4 digits starting from the right. So we have 1 partition for 0 0 1 0, and then the next one would be 1 0 1 1, and then the next would be 1 1 1 1, and the last portion for this number is number 10 now, or 1 0. Now since it does not reach 4 digits, we add 2 zeros to the left of this 1 and 0 to make it 0 0 1 0. And then going back to our conversion for 8 4 2 1, so that means 0 0 1 0, it's only on the position of 2, so that will be just 2. And then 1 1 1 1 is of course 8 plus 4 plus 2 plus 1, that's equivalent to 15, which is in hexadecimal equivalent to letter F. And then you have 1 0 1 1, so that's 8 plus 2 plus 1, that's 11, which again is equivalent to letter B in hexadecimal. And then this last portion will be equivalent to 2. So the equivalent of this binary number 1 0 1 1 1 1 1 0 1 1 0 0 1 0 is equivalent to 2FB2. During the examination or any assessment for that matter, you have to make sure that your numbers 10 up to 15 are converted into its alphanumeric form. So it should be FB2 here, not 2, 15, 11, and 2. Alright, so the next one is we're going to learn how to convert decimal to hexadecimal. So just like the other video that I have mentioned for other forms, you need to convert it by dividing the number by 16 for the whole numbers and repeatedly multiplying it by 16 for decimal numbers. So let's start off with 1610 in decimal form, convert it to hexadecimal. So to convert 1610 to hexadecimal, divide 1610 by 16, you get 100 with a remainder of 10. Okay, now note again that we only focus on the whole number. The remainder will be set aside. At the same time, it should be converted into alphanumeric if its numbers 10 to 16. So 10 here is equivalent to A, and then we focus on the whole number, which is 100 divided by 16. That would be 6 with a remainder of 4. So again, focus on 6, set aside the remainder, and continue dividing the number 6 by 16. That will be 0, and that will be that will give you a remainder of 6. So since this is a decimal number, we need to read it from the bottom up. So that would be 6 for A, and that is your equivalent of your decimal form 1610. Okay, so if it is in decimal form like 0.811 in decimal, convert it to hexadecimal, you need to continuously multiply it by 16. So 0.811 times 16, that will give you 12.976. So you set aside the 12 and automatically convert them into, or that number into its equivalent in alphanumeric. So that's equivalent to letter C. And then continue with the 0.976, multiply it by 16. Again, set aside the whole number, which is 15. That's equivalent to letter F. And continue multiplying the remainder, the decimal part, which is 0.616 by 16. So 0.616 times 16 is 9.856, and that will give you a whole number of 9. And depending on the number of digits required from you, you may continue multiplying 0.856 by 16 if necessary. So you need to find out how many digits will be required in the computation so that you can multiply the decimal part that number of times as well by 16. And then remember, but since this is from decimal to hexadecimal, you need to read it from the top to the bottom. So that should be CF9, and that is now the equivalent of 0.811 in hexadecimal using only 3 digits. Okay, now the next one is going to be converting octal to hexadecimal. So in converting octal to hexadecimal, we need to convert the octal number to decimal or binary first, and then convert it to hexadecimal. So just like what we have learned before, if you're going to convert octal to decimal, you simply need to look at the value, like 21 here to in octal to decimal would be 2 times 8, 8 because it's an octal value. So to the power of 1 because that's a placement. So if it's 21, 1 is at position 0, 2 is at position 1. So 2 times 8 to the power of 1 plus 1 times 8 to the power of 0. Alright? So that will give you 17 in decimal. And then to continue, convert this decimal number into its equivalent hexadecimal, which is in this case done by simply dividing 17 by 16, and then we set aside the whole number, we put the remainder, we continue with the remainder here. So the whole number is 1 remainder 1, so the whole number will be continuously divided by 16. You get 0 remainder 1, and we read it from the top to bottom, so that will be 11. So in other words, your 21 in octal is equivalent to 11 in hexadecimal. Now this is just one way of converting it. So we're converting it from octal to decimal and decimal to hexadecimal, because there is no direct conversion from octal to hexadecimal. But another way that you can do this is you can convert octal to binary and then binary to hexadecimal. So depending on how the instructor will give you further details during the exam, you may convert octal to hexadecimal via decimal or via hexa or via binary. Alright, so to summarize, we have just learned how to convert binary to hexadecimal, and that is by grouping the numbers by 4 and remembering the placement of 8421. We also learned how to convert decimal to hexadecimal, and that is by either dividing it by 16 or multiplying it by 16. So if it's a whole number, we continuously divide it by 16 and read it from the bottom up. If it is a decimal part or decimal number, we convert it by multiplying the whole number or the decimal number by 16 and setting aside the whole number and continuing with the decimal part until the number of digits is achieved. Now, we also learned how to convert octal to hexadecimal, and that is either by converting it through decimal first and then converting the decimal value to hexadecimal, or converting octal to binary and then binary to hexadecimal. So that should depend on the instruction given to you. Alright, so I hope you learned something from this video. Thank you.